Thank you very much. Hello, everyone. I'm excited to be here at this, inaugural Open Source 101 conference. My talk here, the perfect library tooling. I use perfect in quotes because it's obviously highly subjective. These are naturally my own opinions, but it's basically the talk I would have liked to have heard when I was starting out building libraries, a few years ago, because libraries for developers have different concerns than apps for users. So these are basically the learnings over the years doing tooling type things that I've done, both in open source as well as on the job at Stitch Fix and previous jobs. So, um, and then also just watching other people who are more prolific in what they've done. So I want to let you know that I have tweeted out a link to these slides. So if you go to my Twitter account, BenMVP, you should see a link there, or you can go to my website, benmvp.com, or here at the bottom left of the screen, I have a bit.ly link to the slide. So lots of different ways to find it. I like to include links to all sorts of resources about topics that I can't deep dive into. So I'm sure that you're going to want to have the link to the slides to review later. So I'm also going to try to pay attention to the chat as well. Like normally we would be in a venue and I would be able to see your faces. So when there's puzzled looks, I'd be able to know I need to explain something more, or there would be excited looks and I would know that, people are really getting it. So if you want to leave comments in the chat throughout, I'll try to pay attention and answer any quick questions, but the main questions will be at the end. And also, if you want to just leave comments like, "Woo, this is great. This is amazing. Ben is awesome." That's totally fine too. You're more than welcome to do that. So moving on, let's kind of move into this. Whenever we're talking about non-end user features like tooling, we need to step back and we need to ask ourselves, what exactly is the benefit? Like, does any of this actually matter? Because if it's not a feature for the end user, then it needs to be a feature for the developer so that they can build faster or better or what have you for the end user. Because the goal is ultimately the end user of our product. Otherwise, we're going to find ourselves bike shedding over meaningless things. So Kent C. Dodds, he wrote this blog post that says exactly that. It's about a year old or so. And it says that basically we should always measure our success based on how well we can deliver what the end user wants, right? So our choice of tooling should be based on that goal and no more. All right. So in this case, that means that this kind of focus on the user principle still applies, except that this time the user is the developer. Like the libraries that we build in open source or internally will be used by other developers. So instead of talking about how to write the code, that's not what I want to focus on. I want to focus on basically everything else involved in building a JavaScript library. So everything that enables developers to build user experiences with our library. Because it doesn't matter how good our library code is if it's difficult to use. So before we really dive in, I would like to get everyone to stand up. You can feel free to stand up at your desk because I want to do 10 squats together. All right. It's afternoon for some people, morning for some others like myself. And I want to get the blood flowing before we get started. Okay. And I have no idea if you're going to do this with me. So you may just watch me do 10 squats by myself, but that's okay. We're going to do the 10 squats together. All right, here we go. Ready? 1, 2. I hope you're doing it with me. 3, 4, 5, and we're halfway there. 6. Here we go. 7, 8, almost there. 9 and 10. All right. Great job. Great job. Woo, if you did the squats, let me know in the chat. I'd love to know that I wasn't the only one. Hopefully, I wasn't the only one. But anyway, let me formally introduce myself. My name is Ben Ilegbodu. I'm a Christian, a husband, and a father. Oh, great. I'm seeing people who are doing the squats. Awesome. Getting the blood flowing. It's a nice way to get started with the talk. So here's my family right here. That's my wife in the background, giving my kids what it looks like, the evil eye. Uh, we've been married for 11 years now. These are our three kids. The one in the back, Simone, our oldest daughter, she's 7. Avery in the front in the yellow shirt, she is 4.5. And Asher, copying his big sisters in the middle there, he's 2. And we live in the San Francisco Bay Area in a town called Pittsburgh, not to be confused with Pittsburgh, Pennsylvania. It's Pittsburgh, California. And I'm also a Google developer expert and Microsoft MVP in web technologies. Thanks for the shout out for my family. I appreciate it. I am a principal front end engineer at Stitch Fix. So I work on our front end platform team. We work on building out our React design system, as well as focusing on front end infrastructure to allow other devs to focus on the actual features they're building for the users. So if you're not familiar with Stitch Fix, quick little blurb, I guess. We're an online personal styling service. So we take the effort out of shopping by providing you like a selection of clothes picked just for you. And we send it directly to your door, which is convenient nowadays, on a frequency that you choose, or you could just shop directly based on clothes that have been picked for you. So we combine technology, my side of the business, data science, as well as human stylists all together to create a great experience for you. And we're hiring. So please visit stitchfix.com/jobs and you'll see some of the openings there. Unfortunately, it's US only. Our headquarters is in SF, but even before COVID, we had like 50% of the engineers were remote already. So we have a very good remote culture there. So that was about Stitch Fix. Enough about me. Let's talk about this perfect JavaScript library. All right. So uh, again, the info that I'm going to suggest applies to both open source packages as well as internal packages to your company. So things that you may build that multiple teams in your company are using. And I want you to remember, we're shifting our focus away from we're shifting our focus to what our users need, which are the developers. So it's not necessarily what we care about. It's what will help other developers. So those developers could be within your company, or they can be a developer around the world who's using your open source package. So let's jump in. The first thing we need, I suggest, is helpful docs. So we need docs that explain how to install the library, examples of how to use the library, and then like a full API spec once I kind of already know how to use the library. So then the question for us is like, what makes helpful docs possible, right? Well, my suggestion is that you write the docs first before implementation. Why? Because actually writing good docs is pretty hard, so writing docs beforehand makes it, a little bit easier. Like for one, we're more likely to have cohesive docs because we're writing it all at the same time. So like formatting, inclusion of examples, like all of that stuff will be happening at the same time. And then 2, we will write the docs when we know how our code works the least, right? Because we haven't written it. So we're better able to put ourselves in the shoes of someone who's new to our library. And then lastly, we can get feedback from others before we even do the implementation. And we're presenting the code or the documentation to them in a way that everybody would see it. So they'll be able to like pretend that they were trying to use the library based upon the docs that we've written. I find that it's a much more approachable than giving someone, an implementation spec written in Google Docs or something even more technical. So then the question is, well, what sort of docs should you write, right? I want you to keep in mind that there are at least 4 types of docs. There are tutorials, how-to guides, explanations, and references. So let me use Lodash as an example. So references would be the traditional API docs for Lodash when you go to the documentation. So, here are the parameters for the pick function. This is what it takes in. This is the return value that it gives back, right? And these are great for those who already know how Lodash works, like in general, right? And they just need specifics. They probably already have it installed in their app. Then there are how-to guides, which are examples showing common use cases for Lodash functions. And they're typically paired with API docs, right? But more complex ones can be full-on recipes or even a whole sample repo of how to use multiple functions together. Then you got explanations, which are blogs, talks like this, videos, etc., to explain maybe why using underscore chain is a bad idea, right? They help clarify or illuminate a particular topic, and they can go way more in depth than the API docs can cover. And lastly, then tutorials. So that would be like a Lodash workshop that we would find on Egghead or Frontend Masters or somewhere else online. And these lessons kind of take the reader or take the person by the hand to build something with Lodash, for instance. So these are perfect for newcomers who may not even know what Lodash is, right? So for your perfect library, this perfect library that you're trying to build, you should have at least references and how-to guides at a minimum. Like at a minimum, you should have the API docs and examples. So, like, this is why library authors are always suggesting help with docs as a way to contribute, because docs are critical and there's a lot to write usually. So, whether you write the docs first or you write them after, here's my suggestion of what your repo's readme.md should look like. These is generally where the docs go on the repo's homepage. And I suggest in this particular order. So, at the top, we can have all the badges you want, package version, build status, number of downloads, stars, whatever makes you feel great about yourself, right? So those can be at the top. Then a short description of the library's purpose, so at least I know that I'm in the right place. And then installation instructions, including whatever necessary peer dependencies are needed. Okay, because sometimes people just leave the installation instructions, assuming that I know exactly what to do. So now we still have to include npm and yarn instructions at the same time, right, for install, because people use both. And then after that, number 4, a quick guide on how to do common things. So there's probably, a handful of functions that people use normally with your library. We'll show quick examples of that just to warm them up. And then you can have the full API docs after that. So these could lead to link to other Markdown files, for instance, one Markdown file per function. But each function or configuration or whatever should have real world examples, like how somebody would actually use this library. So please don't use any foo bar examples because they can be confusing to newcomers, and not like newcomers to programming or development, like newcomers to your library in general. Like, I would like to know exactly how this function is used with examples that you show. Then at the bottom, you can have the technical details. So this is like how this is faster, the technology used, why you decided to write it. I really dislike when this stuff is at the top. Like, I know this was your motivation, but I don't care. Okay. I care about all the stuff at the top, right? You can put that at the bottom if I really got nerd sniped and wanted to know all the details, but I don't want to scroll multiple pages just to get this through this, past this information. And then contributing guidelines, which probably link to a contributing.md file. We'll talk a little bit about that later. And then license info at the bottom. Oh, but I do want to point out one thing. There's this library called Fiddly by Sarah Vieira. So what it does is it will build a static HTML site from your readme.md and other MDs that it links to. So now you can make your library look official, even more perfect by being hosted on Netlify or Vercel or whatever other hosting service. So that's pretty cool. All right. So now we've got these helpful docs that you've provided, right? I can develop my app using your library. Awesome. Like this is a huge first step. But the very next thing I'll need, in my opinion, are TypeScript types from your library. Now, for those who aren't familiar, TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. So this suggestion may be a little bit controversial. It's certainly my own bias because I develop in TypeScript all the time, but the numbers back me up from the state of JavaScript survey. Take a look. So TypeScript has become super duper popular. I think everybody can agree and has sensed that if you are following the community. So 2018, in my opinion, was the year that everyone, quote unquote, discovered TypeScript and got excited about it. So, like, only a third of devs in 2017 had used TypeScript. But then in 2008, it jumped nearly to half, 47%. And then in 2019, it was nearly 60% of devs. And just last year, it was nearly 3/4 of people had used TypeScript, 72%. And now, if we add in all those people who are interested in using TypeScript, it's all the way up to 88%. So that means that nearly 9 out of every 10 developers will need TypeScript definitions from your library if you make it available, especially for open source. So this is all in order for them to be able to write their TypeScript app that uses your library, because we need TypeScript types immediately. So the question for us is, what makes it possible to make TypeScript definitions available? Well, one option is you build your library using modern JavaScript, Babel and friends and such. And then you add TypeScript type definition files to this to definitely typed. It's this repo of high quality TypeScript definitions. Like there's like 7,500 type definitions for all of these packages in there. React is in there, Lodash is in there, Node, even jQuery is in there. So lots of popular libraries that are written pre-TypeScript, they have type definitions there. And basically, these type definitions describe the types of the inputs and outputs of the functions and constants or whatever that your library exports. The drawback, though, of this approach is that you have to know quite a bit of TypeScript in order to generate these files manually. Therefore, my suggestion actually is that you just write your library in TypeScript. That's easier, right? So that there's definitely like a learning curve to TypeScript. Like I don't want to undersell that or anything like that. It definitely takes time to learn how to write TypeScript. But in the interest of serving your users, remember, the developers, writing in TypeScript is probably the best way to provide those type definition files for them, because they end up getting auto-generated from your code, which I'll talk about in a little bit as well. It's also difficult to write types for untyped JavaScript code. Like when code is untyped, we can, make shortcut assumptions like, oh, I already know that this is going to be the case, so I don't have to worry about this. But that ultimately ends up not being allowed in TypeScript. So writing types could be really, really challenging or even impossible based upon how your code is written. And TypeScript also gives us modern JavaScript, right? So it's a win for your developers, and it's also a win for the actual development of the library. So it's cool. I'm actually seeing more and more libraries writing adopting and writing their code in TypeScript for this very reason. Like people who were anti-TypeScript are now like submitting to the fact that yes, this might be better for the users of my library. So I like that. Okay, now let's get a little bit tactical. All right. So now I know how your library works because you gave me very helpful docs. And I now have my TypeScript types to develop with. So from a development standpoint, I'm great. All right. But then, like, while developing, there's nothing more frustrating than coming across a library bug, a bug in the library code, right? Like, I'm really, really trusting initially, and I think the problem is me. Oh, this thing must not be working because I wrote the code wrong. Let me see what I did. Let me debug. Let me put all these console.logs and everything like that. And I spend countless hours trying to debug and figure out what's going on and why it's not working. And I lost all of my hair because I did that the last time. Like, but so for our library, to be perfect, quote unquote, we need to do our absolute best to prevent 100% of bugs. Like there should be no bugs. That's the goal we're shooting for. So then, of course, the question is, what makes our library as bug free as possible? Well, uh, it's the three-headed monster of unit testing with code coverage, linting, and type checking. So type checking comes with TypeScript, which we were already just talking about. So not only is developing in TypeScript good for providing the types to our users, it also is good for the users, the developers, because it helps us avoid bugs. So these are like all the edge cases where something is unexpectedly undefined or you refactor some code and forget to update some function calls or change the structure of an object. Like TypeScript will catch all those things and your code won't type check. And with Visual Studio Code specifically, type checking can happen as you develop. So you're getting immediate feedback that, oh, this thing is undefined. You have to do a if check first, those sorts of things. And then linting comes with ESLint. This can also happen as you develop in your favorite editor. So lots of editors support ESLint inline. So the difference between TypeScript, type checking, and ESLint is that they both kind of catch these non-stylistic errors and such, but ESLint can warn us of likely or potential errors like bad practices or code smells, those sorts of things. Like things we could do that technically are correct, but could lead you into trouble, let's say. And there's also lots of plugins for other packages and libraries, environments like React and such. So then the last one is testing and code coverage that comes with Jest. This allows us to write unit tests, of course. So we test the public API of our library, what folks are actually hitting externally. And it can also check what percentage of code has been tested. Really, the goal is to make sure that you cover all of the edge case branches, like that code that you're not regularly going through as you're developing. It's great to have unit tests so you don't have any regressions. And unit testing really is huge in keeping our library bug free, especially when we add new features or we refactor our code. So in order for the unit test to catch issues, we actually have to write unit tests. That's kind of the give and take of that situation. So I'm guessing most of you all knew all that, right? Hopefully you're already writing unit tests. Hopefully you're already using ESLint and such. But I'm interested in taking it to the next level. So typically you would run type checking, linting, and testing in 3 separate commands. But with Jest projects, you can run them all through Jest. So Jest is a platform that's actually broken up into 3 main parts. So we have the the file collector, I'll call it, in the beginning, and that determines which files to run. And then we have the error reporter, I'll call it, at the end, which displays success or failure. And then in the middle is the runner, I'll call it. And it runs whatever it is that we're validating. So instead of running the just test runner, the default runner, we can run ESLint or TSC for TypeScript, that kind of runner. So this now, which is pretty cool, enables us to do linting in watch mode because the ESLint CLI doesn't support watch mode, but the Jest CLI does. And it also allows us to run all three of these things in parallel, which is nice. But then in the end, we get grouped error messaging together for all the different failures that have happened for each one of the runners. So we simply call Jest as the test script in your package JSON, and it'll run all of them. So Jest projects was actually intended for mono repos so that you can run tests in all these different sub packages, but they can actually be repurposed to use for multiple runners like this. And then we take that test script, right, that was in the package JSON, and we run it in our continuous integration environment. So there are many CI services out there, Circle CI, Jenkins, if you're doing it internally and such. But lately, I've been really enjoying using GitHub Actions. I can use GitHub Actions without having to register for another service, which is pretty cool. So right after this, Brian Douglas, he's going to be giving an extended session on GitHub Actions, I think 2 sessions together. So you should totally check it out. It's going to be in the same place. If you're not familiar with GitHub Actions and you want to learn more. I went to one of his sessions maybe 2 years ago, and that's how I learned about GitHub Actions, and I've been using them ever since. So here's an example GitHub workflow. It runs the test on node 12 and node 14. And the thing I just want to call out is that it's important to run your test on all the node versions that your library supports. All right, so there are way more things that I want to talk about, but I can't unpack it all. So here are some resources, links to things that you can read up on to deep dive more yourself. Okay, so we've discussed helpful docs, right? TypeScript types and our code being bug-free. Now let's bring it home with the last thing I want to talk about, which is that no matter how hard you test and you test and you test and you write unit tests and all those stuff, even using TypeScript, there will still inevitably be bugs, right? No one's perfect. But even if you did write 100% perfect code, your users, other developers, right, will have requests for nice new features that you haven't thought of. So you want to be able to take those changes, get those changes to your users as soon as possible. So from initial bug report or feature request all the way to the NPM registry, you want to make that happen as quickly as possible. So then our last question for us is, well, what does make changes come quickly, as quick as possible? Well, it first starts with the issue itself. So whether it's a bug or it's a feature request, we want as much detail as possible, right? We don't want those things where it says, hey, this thing is broken, fix it. Like, we don't want those kind of issues. Or I want it to do this, do it. Like, we want details about what is needed. So with GitHub issue templates, you can guide the developer into a flow based upon their situation. So they can go through a bug report flow and get started with that, feature proposal, question, regression report, etc. And GitHub allows you to tie labels to each one of these type of issues so that your issues are already pre-classified, which is nice. And also, for bugs, you can have the developer run this package called info. It's a CLI, and it retrieves all this information about the environment, and have them include that into their issue template. So it's a quick way to get system information like the node version, the operating system, like all this things that may impact why there's a bug going on. And without them having to ask you how to get that information, just have them run that. There are a lot of different flags that it supports. Okay. Oh, so let's say I am actually willing to help you fix a bug in your library or add a feature to your library. I'm wanting to contribute to open source. So what can make that process go fastest for me? Well, I need to know a number of things, right? So the contributing.md file provides clear guidelines on how to contribute, because you say PRs are welcome, but I need to know exactly how you want those PRs to go. There is a NVM RC file that you can include, which forces the version of Node to be a specific version using NVM. So we're all developing against the same version. There's a prettier.json file. Prettier provides consistent formatting for everyone. So there's no time arguing about code format in PRs. Nobody wants that. But also it makes developing faster because VS Code and other editors can auto format with Prettier. So I just type a whole bunch of gobbledygook. Well, not gobbledygook. I type a whole bunch of code, not worrying about formatting, hit save, and then it formats nicely for me. Less time spent worrying about formatting. And then there's the pull request template, which ensures the correct format, kind of what we were talking about before. And then lastly, a code of conduct to make sure that everybody's behaving properly. So these are all like various communication files to streamline the process. And in fact, if you're just getting started with the library, there are a couple of scripts that you can run here. And I have these 5 right there. You can set up your license, set up your get ignore, generate that code of conduct using the covgen CLI, and then initialize get and npm, and you're off to the races there. So after the code is written, right, the PR is created. It passes all of the CI tests because you wrote unit tests and you're type checking and what have you. And the code gets merged into main. We need that code to get to the npm registry as soon as possible. So the first step is ensuring that we're generating the correct formats of transpiled code, right? Because if your code is written in TypeScript, or even if it's just written in modern JavaScript with new syntax, you don't want to ship that to the end users. We ship down transpiled JavaScript that we're assured that everybody will be able to run. So these days, for modern JavaScript, you need ECMAScript or ESM format, which enables tree shaking, and then CommonJS or CJS for standard Node. So the main field in a package.json field points to the entry point for the CJS transpiled code. And then you have module, JS next main, as well as side effects that are needed for ECMAScript modules. And I have links towards the end that'll explain exactly what all that means and what exactly needs to be there. Then you have your types field that points to the type definitions that we talked about in the second part, right? And then there are the files field, which tells the packager that's going to package up the package, which files to be included in the package. So this is in contrast to using an npm ignore or yarn ignore. And I have a link that describes why that's important. And then next, we need to do the actual transpiling of the code. So I use Babel to do the transpiling, even with TypeScript, because there is a Babel plugin for TypeScript that allows for transpiling TypeScript to vanilla.js. I don't use Webpack or Rollup because those are, in my opinion, better geared towards creating bundles as opposed to transpiling individual files, which is what I need for creating this published package. And then next is I generate the TypeScript definition files that we had talked about before using the TFC command. So Babel for transpiling code, TSC for generating type definitions. And then lastly, I wrap it all up using the npm run all script that will run all of them in parallel for me, all of those build commands. So then with that build script I just talked about in place, we can now do continuous delivery, the CD of CI/CD. So first here, I run the build command to create all those assets and put them all in the proper place. And then next, we can use semantic release, another CLI, to automatically release this to npm. And it does a whole bunch of things once we merge the code into main or master or some other release branch. So what it does is it makes releases unromantic and unsentimental is what it says. So I can even merge a PR from my phone and it gets automatically pushed to npm in about 5 minutes, which is depending on how long it takes for the builds to run. So there's no more having to push a version commit or having to run a script locally in order to get a new version. Like, it all happens in CI, which is pretty cool. So then releases show up in the GitHub releases tab, for GitHub at least, and it has a detailed changelog about what has changed. It gets automatically created. I no longer have to manually maintain a changelog or not have a changelog, and then no one knows when things change. And then last but not least, I want to make sure that the package that was created is correct. Like, things were put in the right place and it was released properly. So I can use unpackage, that's the most popular one, JS deliver, or even now npm lets you browse the package to see where everything is located. Okay, that was a lot, but there's even more stuff that I wanted to talk about that I didn't get to. And here are, 10 different links about more details about the things that I was describing. So if any of those caught your eye, please take a look at those links after we're done here. So let me recap, all right? Because in totality, that was a lot of stuff. So chances are you missed something as I was going, right? Someone texted you or Slack messaged you, Discord, and you just got distracted, right? It happens. I know it happened. Don't feel bad. So I want to go over everything again, but instead of focusing it or grouping it by user need, I want to focus it on how we would implement the infrastructure. See, someone was honest and said it was Slack. See, I knew it. So as we'll see, is like this perfect repo is a mix of technical and communication things. Just like, the quote unquote perfect developer should also be a mix of technical and communication skills. But that's a whole nother topic. Here it is, all in one slide. You can take a screenshot or whatever you want to do with this. Take a picture of your screen with your phone, whatever. So it starts off with a development experience, right? So we're using Typescript to get modern JavaScript. Use Visual Studio Code is my suggestion. You can get prettier and ESLint and type checking all in the editor. And then there's a slew of repo files, which are docs for your users, as well as other things that communicate how to interact with you and make sure it's easy and safe. And then we got the testing and continuous integration part, using GitHub Actions ideally, and Jest as a platform. So you can do the type checking, linting, unit testing, code coverage. And then last but not least, probably the most important, or at least the most technical, I guess I would say, is the build and continuous delivery side. So Babel for transpiling, like I said, TypeScript for type checking. You probably want to target CommonJS and ECMAScript module formats, set all those fields in the package.json, and then use a CI service to auto release with semantic release there once your code merges into main. And if you want to get real fancy and auto publish your docs, you can also do that with Fidly there. All right. So let me quickly wrap up. This was all the information that I wanted to know, 5 years ago when I started out. And to be honest, it would have been too overwhelming to try to do all of these things. Like, I think I counted 20 different things on the previous slide. Um, I wanted to have the right tooling, but I was more interested in building my library, obviously. And even now, knowing all of this stuff, I still don't have the time to build all these things. So I created this zero config CLI tool that I call BinMVP CLI for obvious reasons, to abstract all of that work. So it handles basically everything but the docs and of course the source code. So the CLI has some options, so you could totally use it, but I built it for myself. So don't expect any PRs to make it more configurable. This is open, but not really open source, I guess. So you could see it in that regard. So it works much like React scripts. If you've ever used create React app, there's a create command and you can pass the lib name to it. There's test and build, which we kind of already described. There's a start, which basically runs test and watch mode. Create basically creates all the files and stuff that you need, sets up the package JSON. And then the integrate script I find interesting in that it basically packages up the library, puts it in a separate temporary folder, and then runs integration tests so I can test just like somebody importing the library and using it directly. So it catches the cases where like all my unit tests pass, but I forgot to export a function to the main index file. So BinMVP CLI uses itself to develop, test, and build itself. So it's kind of like a perfect repo to help create other perfect repos. Look how that works.
Hey,
Okay.
Ben, I need to interrupt you. I'm sorry. Two things. I wanted to remind you of the time. You've got about 3 minutes left. You have a question in the Q&A, and Gail has requested to see your resource slide one more time.
The resource slide. So yeah, so I have a link to the slides online, and there's links there. So if folks want to be able to see that afterwards, you can totally access it. So yes, let me wrap up real quick, and then we can hopefully take a question. So here I wanted to give a quick shout out my friend Jonathan Creamer. He's all about front end tooling, and it's like becoming more popular. There are even roles for this at companies. He works at Microsoft doing this. So he coined the term DevOps for front end tooling, not DevOps, but DevOps because it's front end. So there's a Slack group and a subreddit. So if you're interested in these sorts of things, go ahead and join that. We've been having some meetings to discuss these sort of things. And then lastly, self-promotion, shameless promotion, shameless plug, whatever. I have a newsletter called the BinMVP newsletter. It's a teaching newsletter as opposed to a aggregator newsletter of information. So I talk about TypeScript and React and of course DevOps. So if you're interested in learning something new each week, go to binmvp.com/subscribe and you can subscribe for that. All right. So that's it. I just flooded you with a whole bunch of information. Like I said, the slides are available online on my Twitter account, on my website, binmvp.com, or you can follow the link there that's still at the bottom of the screen, bottom left. So these are things hopefully that you can apply right away in your libraries. But if there's things that I forgot or other things that you're using, I would love to know about them as well. I wanted to give a special shout out to the organizers of Open Source 101, Todd and Danny, for putting this on. Hopefully this is just the beginning of more conferences to come. And thank you all for attending the talk, because there are a lot of other options that you could have gone to. And you could have gone to them during this talk, but you didn't leave. So I appreciate that. Hopefully the talk was worth your while. So hopefully I have time for a little bit of QA. If not, you can always reach out to me on Twitter and I can help you there. So thank you very much.